Good morning all of you. Today we are going to discuss about the subject of theory of computation. So in this subject our today topic is finite automata. So today we are going to discuss with the finite automata concept in theory of computation. Okay. So what is the finite automata in the sense? So this is a one machine which is reading the input symbols as character by character and it forms the meaningful token. So it is reading input symbols character by character. Character by character and it forms meaningful token. So meaningful token. So when one input symbol is called as a meaningful token in the sense, suppose consider integer in programming language we are going to declare with one data variable as an integer a. End with semicolon. Okay, so the compiler is reading the inputs as character by character. So first input reading is I and it moves to the next character n and it moves to the next character t. So after reading I and t, the compiler decides this is a meaningful token which is called as a one keyword in C language. So int is a keyword, recognized token. So this is accepted by the finite automata. Okay. So for this finite automata concept, we will go with one example through transition function and transition diagram. Okay. So consider the transition function in finite automata. So I will give one example. Consider delta of q0 comma a equal to q1, where this is the transition function where this q0 is called as an initial state and this a is called as an input symbol and this q1 is called as a output state of this particular transition function. So this is the common format of how the transition function will be defined in finite automata. Okay, so consider this is first transition function of a finite automata, and again I will give you one more transition function like q1 comma b equal to q2. The same procedure. The q1 is a state of input and b is a input symbol, and for this particular transition function this q2 is called as a output state. So I will add one more transition function delta of q2 comma c equal to q3. Okay, so the input state is q2 and which is reading the input symbol c, and the q3 is the output state of this transition. Okay, so consider this is one example with three transition function. This is first one, second one and third one. Okay, by using of these three transition function, next we will move to the transition diagram. Okay, so the next concept is our transition diagram. Okay, so q0 is initial state, so I can start with first state as a q0. Okay, and from q0 state the input symbol is a and output state is q1. So I will add one more state as a q1 and this flow of transition with the input symbol is a. Okay, for the initial state representation you can mark here one more arrow mark. Okay, so this arrow mark is represents this q0 is a initial state. So from the q0 state input symbol A is reading and it reaches to the state Q1. Okay, so from the Q1 next input symbol is B and it reaches with next state Q2. So I will add the next state as a Q2 and the flow of transition is B. Okay, from the transition function next the flow of transition is B. Okay, and next third transition function, again my input state is Q2 and the input symbol is C and it reaches as a Q3. So again I will add one more state as a Q3. From the flow Q2 to Q3 input symbol is C. So it's reading the C. Okay, and this Q3 is marked with double circle because of there is no further transition function. So I can consider this Q3 is a final state of that particular transition function. Okay, so now consider this is a transition diagram which is constructed from the given transition functions. Okay, so now this A, B, C is a recognized input symbol. Okay, so W equal to A, B, C is a recognized input symbol of this finite automata transition diagram. Suppose this W equal to A, B, C, A is a not recognized input symbol because A, B, C after reaching final state there is no transition state, so I cannot give this A as a one more input symbol. Okay, so this is how the finite automata is accepting the input symbol. So after giving this W word equal to ABC or input symbol W equal to ABC, my finite automata will be recognized. This is accepted input string. But second one, if I pass the second input string, the finite automata will not be recognized by the input string because of this is not occurred by the transition diagram. Okay, so this is simple method how the finite automata accepting with the transition function and transition diagram. Okay, and again we can move the transition functions, extended transition function. Next concept is after getting idea of transition function, we can have a concept of extended transition function. Okay, extended transition function. Okay, so what is the meaning of extended transition function in the sense? Okay, so we have a transition function with flow of execution. If suppose the transition function is extended with one more execution, then we can use the function of extended transition function. Okay, so which will be represented like, suppose the delta of Q0 comma W can be rewritten as the delta of Q0 comma, okay, so the epsilon comma W. Okay, so this is considered one transition function where this transition function is extended with the initial state Q0 comma epsilon with W. Okay, so here what is the meaning of epsilon means the epsilon is a one input symbol but it does not affect any input symbols. If you are using or concatenating with any input symbol W with epsilon, the result is become a W only. Okay, so concatenated with epsilon input symbol, any input word, it cannot be affected with the any input symbol. So we can write it as a epsilon dot W equal to epsilon dot again W is equivalent input strings. Okay, so this is the simple concept of how the input symbols are accepted by the finite automata concepts. Okay, so in a finite automata, suppose this concept where we are using in the practically. Okay, so consider pattern matching. The concept of pattern matching. So what is the meaning of pattern matching? Suppose everyday life we are using the mobile phones. In your mobile phones, if you are unlock your mobile phones, there is a method of patterns. Okay, we are using the patterns. Okay, so in this pattern, if you are going to use with the patterns unlocking, you have to type each and every character. After that, it will be unlock the mobile. Okay, so like suppose I am going to give the word 112233. So this is my pattern. Consider this is my pattern. After giving this, the finite automata is reading the first character. Yes, it's verified by the finite automata, so it is recognized, and it moves to the next character 1. So it is verified. It is also verified by the finite automata and recognized. Okay. So up to like this, it will reach the final character of the 3. So after ending of the pattern, the full pattern is recognized by the finite automata. Okay, so this is called as a how the pattern matching is one of the application of a finite automata transition. Okay, so suppose this input symbol is, we will discuss with one diagram of this passcode. Consider the state of Q0 and Q1 and Q2, Q3. Okay, so now I will use the passcode 1 1 2 2 and then Q5. So this is 3, and then Q6. So this is 3. So this is our final state. Okay, and this Q0 is initial state. So this state is called as a initial state of the transition. Okay, so now this is how in finite automata representation one pattern is recognized through the diagram. Okay, so consider 1 1 2 2 3 3. So first input is reading. So the first input reading is Q0 to Q1. The input is 1. Okay, and next it's reading to 1. So next 2 2 and 3 3. After reaching the final state, so my given pattern is recognized by the finite automata. Okay, so suppose in between, suppose if I missed, consider if I missed this transition, so this pattern is not recognized by the finite automata. Okay, so the correct finite automata recognition of the given pattern is 1 1 2 2 3 3. Okay, so by using of this transition diagram, our finite automata is telling this pattern is recognized by the finite automata transitions. Okay, so in this diagram even we can construct the transition function also. Okay, so we'll see the how the transition function, because in previous example we have given from the transition function to transition diagram constructed, but in this case transition diagram is given. So from this transition diagram, how the transition function is derived. Okay, so consider the first flow of execution Q0 to Q1. So the delta of my transition function Q0 comma input symbol is 1. So what is the output transition, in where the Q0 along with one input symbol is reaching to which state? Q1 state. So the output is Q1. Okay, and next transition function delta of Q1 and next input symbol is 1. So where it is reaching? Q2 state. Okay, and next delta of Q2 comma 2. So where it is reaching? Q3. So Q3 is the output state of Q2 on 2. So next the delta of again Q3 comma 2, where it is reaching? Q4. So the Q4 is the output state of Q3 on 2. Okay, and next we now we are in Q4 state. So the delta of Q4 comma 3. So where it is reaching? Q4 on 3. The state is Q5. Okay, and next the delta of Q5 comma one more last input symbol equal to Q6. Okay, so this Q6 is marked as a star because it is a final state. Okay, so after reaching this final state, we will have a input pattern recognized 1 1 2 2 3 3. Okay, so this is the method how if the input transition functions are given, how we will construct transition diagram through the acceptance of finite automata. And if the transition diagram is given, how we will be converted into a transition functions. Okay, so next class we will discuss about how this finite automata is accepting the input symbols. Okay, so along with one example. Okay, thank you.